Okay, this is chapter 1 to 6 chemistry grids required for the final for term 3. Before starting, shout out to Bob. He's really going through something recently. ف I feel with you, Bob. المهم, question 8. Name the most suitable glassware. Okay, this takes you back to chapter 1 chem. Okay, to prepare a solution, it's always volumetric flask. Okay, whenever you're preparing any solution, volumetric flask. And it's actually in the chem book. Whenever you want to prepare a solution, you take a volumetric flask. Measure a specific volume to the nearest 0.05. Okay, when measuring volumes, okay, when it's specific and it's very accurate, like to the nearest 0.05, you use a pipette, pipette, whatever, pipette, whatever. Okay, when you're measuring variable volumes, okay, variable means you're not really sure about it. Okay, even though it's still accurate. Okay, but it's less accurate than the pipette, pipette, whatever. Okay, it's less accurate than that one. Okay, you'd be using a burette. Okay, burette. Okay, and if you want to mix liquids, okay, it just take a beaker. Okay, don't say conical flask. Conical flasks, we don't want that. Okay, beaker is easy small. Okay, but maybe it comes multiple choice, so just make sure you know conical flask. And you're required to obtain salt crystals from a solution, salt solution. List in the correct order the steps. Okay, so obviously you know that you have to use crystallization, but the steps for crystallization, memorize them. Okay, you heat the solution in an evaporating dish, but you have to on a flame, but you still have to leave some liquid. Okay, because if you boil it dry, it's gonna burn, and we don't want that. Okay, so after you heat it until only some of the liquid is left, okay, still most of the liquid evaporates, you transfer it to now a water bath. Okay, and now on the water bath you can heat it until all the liquid evaporates. Okay, so step 1 is to place an evaporating dish, heat over a flame, and wait until most of the liquid evaporates. Step 2, transfer to a steam bath and evaporate all the liquid. Name the most suitable technique to separate a soluble salt from an aqueous solution. So whenever you want to get salt, you use crystallization, okay? But you may use distillation if you want the water, right? If you use crystallization, you lose the water and you're left with salt. But if you use distillation, you're left with salt and water. Okay, an insoluble sulfur mixture, obviously you use filtration. Insoluble means it doesn't dissolve. Like for example, water and sand, you would use filtration to separate the sand from the water. Question 11, what is meant by each of the following terms? Filtrate and residue. Over here in question 11, the filtrate is the liquid that goes down. So the one down here is the filtrate. I remember this used to come. And then the residue is the thing that's always left up. Okay, residue in English means left over. Okay, and it's left. Okay, it's residue. You never like the residue. Residue is the solid that's left behind. Okay, the filtrate is the nice clean stuff that's filtered and goes through. Residue is the stuff that's left behind. How do you separate the sand from a mixture of sand and seawater? Obviously by filtration, right? We'd have to filter off the sand. And label the setup using filtration. We said the stuff that's left over is the residue. I'm not gonna write it, it's just all here. It's residue, okay, and this thing that goes down is filtrate. I remember this game. This is the conical flask, okay, or whatever flask they give you, okay. Just say flask or conical flask. Better to use conical flask. And obviously this is a funnel, but say filter funnel. Don't just say funnel. You never know. They might deduct marks. Okay. What's the next grid? Okay, what is the name of the process by which a substance changes from solid to liquid state? I think that's just melting. I mean, everybody should know this. Okay, and what is the temperature at which it changes from solid to liquid? Obviously, the melting point. Question 4, what do we call, oh, that's a lot. The process by which a substance changes from solid to liquid at a different temperature. We just said it's melting or fusion, I guess, whatever. What do we call the process by which a substance changes from liquid to gas? Obviously, evaporating or vaporization. Okay. What do we call liquid to solid? Obviously, freezing or solidification. Okay. What do we call from solid to gas? Obviously, sublimation. Okay. And then gas to liquid, that's condensation. If they asked gas to solid, that would be deposition. So I don't know if that's required. I remember we took it before. We don't need the tops. The next grid is question 3. Okay. Question 3. Explain the following equation in words. I think they just want 2 molecules of hydrogen react with 1 molecule of oxygen to produce 2 molecules of water, I think. Yeah, 2 molecules of hydrogen react with 1 molecule of oxygen to give 2 molecules of water. How are reactions read? Okay, if it has a subscript, that means it's a molecule. Okay, so in this case, it's a molecule. Okay, but if it was 2H like this, no subscript, 2H, that would be two atoms. Okay, that's how you distinguish it. Okay, and obviously, if it's more than one letter, then it's a molecule. Okay, but if it has a subscript, then it's a molecule. Okay, please pay attention to that. In the exam, they got it differently. What is the atomicity of each of the following? You ignore the coefficient. You just count how many atoms. This is 1, this is 3, so obviously 4. This is 1, this is 2, that's 2. This is 1, this is 4, this is 5. So that means 5. 1 and 2, 3. Okay, I think, yeah, 4, 2, 5, 3, easy. Question 5. Which of the following is a pure substance? Carbon dioxide, CO2. Yes, it's a pure substance. A liquid that freezes at 0 degrees Celsius. Okay, I think that's also yes. Yeah, A, B, D, E. Okay. Copper sulfate solution. No. Solid iron, D. Okay, yeah. Nitrogen gas, N2. I think what I remember, the definition of the pure substance is a compound or an element. If I'm not sure, let me double check. Yeah, so a pure substance is either a compound or an element. So carbon dioxide, CO2, is obviously a compound. Okay, it's pure. It's only carbon dioxide. A liquid that freezes at 0 degrees Celsius is water, right? H2O. Okay, and since it's freezing at exactly 0 degrees Celsius, that means it's pure water. So that means it's pure. Okay, pure water. Okay, but for example, seawater isn't pure because it's made out of water and some salts. It actually freezes at, I think, a lower temperature, I think -5 degrees Celsius. Okay, since it freezes at -5 degrees Celsius, it's not pure. It's seawater. It's water plus some salts. That means that's not pure. But if they tell you it freezes at 0 degrees Celsius, that means it's pure H2O. Copper sulfate solution, it's a solution. It's wrong. Copper sulfate solution means copper sulfate plus H2O plus water. Okay, we don't want that. Okay, I think it's plus water, but anyway, we don't want solutions. Okay, we want pure substances. Solid iron, that's only Fe. Fe is iron. Okay, it's Fe, 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 Fe. It's only Fe, so it's solid. So that means it's pure iron. Okay, nitrogen gas, obviously it's only nitrogen gas. It's only N2. It's pure nitrogen. So that's correct. Okay, question. This is 8. Compare the ability of different states to change their shape and volume using the particle model. What? Oh, okay. Yeah, this comes. I remember this coming. Okay, gases have no definite volume or shape. Okay, I think you should just memorize all of this. They will occupy any volume they are placed in. Okay, we know this. Gaseous particles move easily, and there is a lot of empty space between the particles, so gases are easily compressed. Okay, I think this comes multiple choice. No, gases are easily compressed. You choose it. Gaseous particles have space between them. You choose it. Gases have no definite volume or shape, or you choose it. They occupy any volume. You choose it. Okay, liquids. Liquids have a definite volume but an indefinite shape. They take the shape of their container. Okay, sometimes like مثلا if they put for you liquids have a definite volume and shape, you don't choose that because it has an indefinite shape. Liquids are practically incompressible due to the limited space between the particles, so the particles are not very spaced out. However, the small spaces between the particles allow to change shape as the particles slide and flow past each other, so there is small space between each other. But solids, okay, remember that they can slide and flow past each other. For liquids, the keyword is slide. Okay, solids have a definite volume and shape. Okay, both shape and volume definite. They are practically incompressible. Why? Because there's no spacing between the particles. It's very minute, minute. Yani, it's not minute, it's minute. Minute, yani very small. Okay, the solid particles are so tightly packed that they cannot move with respect to each other, so they can only vibrate. Okay, question 13. A mole is, I think, a mole should be 6.02 times 10 to the power of 23 particles, right? Okay, 6.02 times 10 to the power of 3. That's what a mole is, okay? And is the number of carbon atoms found in 12 grams of carbon 12. And this came, by the way, I think remember this came. This comes in some exams. A mole is 12 grams of carbon 12. Okay. Question 14. How many moles and atoms are present in 8 grams of oxygen gas? Okay, use Avogadro's number as how do you solve this? Okay, mole, you just do m over m. Okay, yeah, so I guess to find moles, you just do n equals m over m. So 8 grams over oxygen gas O2, 16 times 2, 32. At this point, I shouldn't be explaining what I'm doing. This is 0.25. Let me check if, okay, moles, and they want atoms, I think. Yeah, moles 0.25. And then always number of atoms, number of atoms. These are the first formulas we took in chemistry. It's n times Na times atomicity. Times atomicity, if I'm not wrong. Okay, yeah, okay. N times Na times atomicity, and Na is Avogadro's number. So in this case, it would be 0.25 times 6.02. No, they said 6.0. So 6.0, please pay attention, huh? Sometimes you say 6.0, sometimes 6.02 times 10 to the power of 23 times the atomicity. In this case, the atomicity is 2 because we have 2, huh? Okay, and you get 0.5 times 63. Should be 3 times 10 to the power of 23. Yeah. Okay. Just I'll write down the formulas here for you. Okay, moles. Okay, moles is N equals M over M. Molecules is number of molecules is N times Na. Okay, and then atoms is the same thing, N times Na times atomicity. Okay, these are the grade 9 chem formulas we took a long time ago. Okay, question 15, practically the same thing. How many molecules are present in a sample of 1.8 grams of water? They're saying use Na as 6.0 times 10 to the power 23. Okay, molecules is N times Na. So first we need the moles. How do we find the moles? N equals M over M, so 1.8 grams over the molar mass 18, and you get 0.1. So N times Na would be 0.1 times Avogadro's number 6.0 times 10 to the power of 23, 10 to the power of 23. So it should be 6.0 times 10 to the power of 22. Yes, okay. Question 16. How many moles are present in a sample of 3.0 times 10 to the power of 23 molecules of H2S? Okay. Sometimes they might ask the moles and they give you molecules. Okay, remember always the rule for molecules is the number of molecules. Okay, number of molecules. Okay, is N times Na. Okay, so we have the number of molecules given 3 times 10 to the power of 23. Okay, equals the N. We want the moles. The N, yeah, we were trying to find it. Okay, times Na, which was always given 6.0 times 10 to the power of 23. Okay, so can I find N? Of course I can. Just take 6.0 times 10 to the power of 23 to the other side and divide, and you should get 0.5. I think 0.5. Yeah, 0.5. What is the mass in grams of the above sample? How do we find the mass if you have the moles? Remember, N equals M over M. Yani this is, at this point, everybody should know. This is basic chemistry. So 0.5 equals the mass, we don't know, over the molar mass of H2S. So H2S, how do you find the molar mass? If hydrogen is 1, S is 32. So 2 times 1 is 2 plus 32, 34. H2S is 34. Just find the molar mass. You cross multiply and you should get 17. صح? 17 grams. Always remember to put the unit, please, 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 please. Question 17. What's the mass of 2 moles of CH4? Okay, again, N equals M over M. So we have 2 moles, so 2 equals mass over the molar mass of CH4. And molar mass of CH4 is 16. Just add them up. 2 times 16, 32 grams. Right? 32 grams. Okay. Find the number of, oh no, 18. How many moles are contained in a sample of 1120 centimeter cube of methane CH4 at STP? Okay, always remember that N also equals, for volumes, it's N equals V over Vm. Okay, Vm is 22.4 at STP, 24 at RTP. Okay, and volume must be in dm cube. Okay, find okay, in 1120 centimeter cube. Okay, so we want the moles and we're working with volumes, so it's gonna be V over Vm. And since it's STP is 22.4. Okay, 1120 centimeter cube to dm cube is gonna be, you have to divide by 1000. Okay, to convert from cm cube to dm cube, remember you divide by 1000. Okay, so this 1120 is going to be 1.12. Okay, then 1.12 divided by 22.4. What do you get? I'll just look at the answer. You get 0.05. Okay, which is 5 times 10 to the power of negative 2. Okay, whatever you want, scientific notation, I don't care. Okay, find the number of moles of CO2 present in 0.36 dm cube at RTP. Okay, remember, okay, they gave you RTP is 24. So N equals V over Vm. So we want the moles. Okay, they give us the volume 0.36. And they give it in dm cube, so they're being generous. Okay, and Vm is 24. You just divide these, 0.36 divided by 24. You get 0.015 or 1.5 times 10 to the power negative 2. Okay, question 20. A compound has a molar mass of 78. If its simplest formula is CH, find its molecular formula. Okay. Okay, this one's a bit tricky, but once you understand, it's very easy. Okay, if its simplest formula is CH, okay, that means the original formula, let's call it CX HX. Okay, let's call it that. Okay, Why? Because, you know, to go from your original formula to your simplest formula, you divide something by the whole equation, okay? And let's say that's x, okay? CX, okay? And you need to find the molar mass. You multiply the subscript by the mass of each one. So, like for example, CO2, if C is 12 and oxygen is 16, we do 1 times 12 plus 2 times 16, right? Okay, that's just an example. For here, CXHX, okay, that would be what our formula is, right? It would be x times 12, okay, I'll use the different multiplication sign. It would be x times 12 because carbon is 12, okay, plus x times 1, right? And what does that equal? It equals 78. So you're gonna get 12x plus x equals 78, x equals 13, x equals 78, x equals 6. So that means my molecular formula would be C6H6. Okay, that's how you solve it. Okay, the way they explain it in the solution is a bit tricky. I don't like it. Okay, what they did, they put n outside and they distributed the n. Okay, since it's 12, like CH is 13, right? Oh, that would make more sense actually. Well, whatever you want. CH is 13, okay? You have to multiply this 13 by something to get 78 because, you know, we divided by something to get 13, okay? Let's just call that x. So 13x equals 78, x equals 6. Oh, so that means C6H. Okay, yeah, I guess that works. For an easier way would just to be add up the masses you have. Okay, C 12 plus 1, that's 13. As divide 78 by 13, you get 6, and then it's going to be C6 H6. Okay, whatever. I think in the exam, I think they gave something like CH2, I remember, and I think the answer was C5H10. This was a long time ago, back in grade 9 they gave us this. But المهم, the most important thing to do is just add up the masses you have, then divide by the molar mass given. Okay, okay, yeah. For classify whether it's physical or chemical, always remember if it's a physical change, that means the composition of that substance is not changing. Okay, burning a piece of wood, it's a chemical reaction, and you know it's combustion. For those of you who are watching this now, you should know that burning is chemical reaction. Okay, it's burning something with oxygen, so obviously A is a chemical change. Uh, Heating a gaseous hydrogen oxygen mixture until it pops. Obviously, if it pops and you're heating it, that means something happened. There was a chemical reaction. So obviously, it's also a chemical change. Dissolving copper sulfate in water to obtain a blue solution. I mean, you're just dissolving. Nothing's really happening. So that should be physical. Melting wax. Again, you're just melting. Nothing really happening. Melting, evaporating, condensating, these are all physical changes, okay? Because the substance itself is not changing, it's just changing the state. So C and D should both be physical changes, yes. E, crushing some salt crystals into powder. You're just crushing it, making it smaller. It's still salt, so it should be physical. F, boiling water until it evaporates and condensing the steam. The end product is all water. It's water, water, water vapor, but it's still H2O, so it should be physical. Boiling an egg in boiling water for 2 minutes and then cooling the water. Okay, the egg, I think, yeah, it should be chemical, right? Yeah. So once you boil an egg, it turns, it's not the same chemical composition. I mean, you're cooking it. You know, cooking is a chemical change. It's not a physical change. Then heating a piece of paper until it turns black, then cooling it. Obviously here, if it turns black, that means something happened to the chemicals in the paper. So that means it's a chemical change. And cooking, obviously, cooking, you guys know, is chemical. Burning magnesium ribbon, burning is chemical. So these are chill. Oh, how many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 parts. Okay. Okay, endo or exo. Burning a piece of wood is releasing heat, so obviously exo. Yeah. Okay. Water solidifying to ice. Always remember, solid, liquid, gas. Water solidifying means it's going from liquid to solid. Okay. I think that's exo. Okay. Is it exo? I think B is exo. Yeah. If you're moving to the left, it's exo. Always remember, when liquids are less tightly packed than solids. Okay. When bonds are being formed, you're releasing energy, so it's exo. Okay. So always remember, when you're going to the left, it's exo. But when you're going to the right, it's endo. So this is exo. This is endo. Okay. Dissolving sodium hydroxide in water, which makes the solution warmer. So heat is being released. So obviously exo. Okay, I'll write exo. Exo. Okay, melting of dichlorobenzene. Melting is going from solid to liquid, so it's going to the right, so it's endo, because it needs to absorb energy. Okay, to split the bonds to make it a liquid. It should be endo. D is endo. D is endo. Okay, endo. Heating water from 20 to 80. It might say heating, so people say, oh, exo. No, you're absorbing energy. When you want to heat, you want to absorb thermal energy to raise the temperature. You see how the temperature is increasing? It's because the thermal energy is increasing. How can the thermal energy increase? It can only increase by absorbing it. So since you're absorbing energy, it's endo. Okay, heating water from 20 degrees to 100 degrees, again, endo, because it needs to absorb energy to raise the temperature. The burning of a magnesium ribbon in air, it's burning, again, exo. Burning is always exo. The reaction that takes place when a spark is introduced to a mixture of hydrogen and oxygen, obviously, it should be exo, since it pops, I think. What part is it? H, exo. Yeah. Uh, any reaction or process that consumes heat energy. Consumes, yani, I think absorbs. So should be endo. I is endo. Yeah. Consumes means you absorb. Okay. Consumes means absorb. So it's gonna be endo. Okay. Cooling liquid pyridichlorobenzene until it solidifies. So you're going from liquid to solid. So it's obviously exo. Okay. The decomposition of water into hydrogen and oxygen gas. Okay. You're splitting bonds. So it should be exo. I think it should be exo. Okay. Oh no, no, endo, endo. Wait. Endo. Akid endo. Because you're splitting the bonds, it needs to absorb energy. Okay, there's bonds between hydrogen, oxygen, so it needs to absorb energy to break these bonds in between them. Okay, that's why. Okay, so obviously endo. Any reaction that releases heat, obviously exo. Condensation of steam. Condensation means going from gas to liquid, and going to the left is always exo. Okay. Sublimation of iodine. Sublimation is going from solid to gas, so that's endo. Because as you're going to the right, it's endo. Vaporization of ethanol. Vaporization is going from liquid to gas, so it should be endo. Let me just make sure N and O are, yeah. Okay. P, ammonium chloride. Let me take this off. Ammonium chloride dissolving in water, which causes the temperature to drop. Okay, the external temperature drops. Okay, that means it's endothermic because it absorbed energy. Okay, from the surrounding. Endo. Yeah, there you go. That's it. Yeah. Okay. Question 3. In chemical reactions, what can you say about the conservation of mass? Okay, always remember, chemical reactions, mass is conserved. Okay, number of atoms is conserved, molecules is not conserved, and I don't think moles are conserved. Let me check. Okay, mass is conserved. Okay, atoms is conserved, and molecules and moles are not necessarily conserved. Okay, so you can see here the sum of the masses of the reactants is equal to the masses of the products, and the total number of each type of atom on the left is equal to the total number on the right. Okay, we should get a question about it, I think. Okay, if 15 grams of substance A combines, so 15 grams of A plus 8 grams of B, okay, to give 20 grams of C plus X grams of D. How many grams of D? I mean, it's not rocket science. 15 plus 8 is 23. 20 plus X should be equal to 23. How much would it be? 3 grams. I think, am I tweaking? Yeah, it's good. 3 grams. Question, what's next? Okay, 5, balance. Okay, I think everybody in term 3 of grade 10 should know that, should know how to balance, okay? NH3 plus O2, let's check. Nitrogens are balanced on both sides. Hydrogen, you have 3 here, you have 2 here. When you have 3 and 2, it's easiest to multiply by 2 here, multiply by 3 here. Okay, so now I have 2 nitrogens here, so I have to put a 2 here. Okay, so let's check now. I have 2 nitrogens, 6 hydrogens, 6 hydrogens. Okay, here I have 4 O2s. Oh, I have 4. Okay, I'm in a pickle here. 4 O2s. Here I have 2 O2s. Sorry, I have 7 O2s, because 3 times O, and then 4. You could put 7 over 2, I guess. I think they want it differently. Yeah, okay. So you could put 7 over 2, okay, and keep it like this, but I think they want whole numbers. So if they want whole numbers, the easiest way I like to do, okay, is after you get the fraction, you want to get rid of the fraction, you just multiply the whole equation by 2, and it becomes 4. It becomes 4 here. Okay, and then this becomes, obviously, so when you multiply by 2, you get rid of the fraction. This 3 becomes 6. Okay, and then this 2 becomes 4. Okay, so that's what I like to do when I'm working with a fraction. Okay, if they ask me for whole numbers, look, what I did at the start was 2 here, 3 here, and then it was 2 here, yeah, and then 7 over 2, 7 over 2, because it's balanced. now I have 7 oxygens on the left, 7 on the right. Okay, but since it's a fraction, you want to get rid of it, just multiply everything by 2. This becomes 4, this becomes 7, this becomes 6, this becomes 4. Okay, that way you got rid of the fraction easily, and it's now balanced. And that's actually the correct answer. Okay, 4, 7, 6, 4. Okay, okay, 5 carbons here, and you have 1 carbon here. So obviously multiply by 5. Okay, let's continue. You have 12 hydrogens here, 2 hydrogens here, so obviously multiply by 6. Okay, let's check now. Am I balanced? Okay, I have 5 times 10, so 10 oxygens, 6 oxygens, so 16 oxygens. So obviously I have to multiply by 8 here. Okay, 5 carbons, 5 carbons. 12 hydrogens, 12 hydrogens. 16 oxygens, 16 oxygens. So is this balanced? Yes, it should be. So 865, 865. Okay, Na plus Cl2 to produce NaCl. Okay, two Cl2s here. There's 2 Cl's here, so obviously it should be 2 here. But now I have 2 Nas, so this should be 2. Should be 2, 2 here. Is that correct? 2, 2. Okay, NaO2, Na2O2. Okay, oxygen is balanced here. So I need 2 sodiums here, so let me just put that 2. Is that balanced? So it's just a 2. Yeah, just a 2. These are the easier ones. AlCl2, okay. Here I have 2 Cl's, here I have 3. So the logical way to be multiply this one by 3, multiply this one by 2. Now I have 6 here, 6 here. Okay, but I have 2 aluminiums here, so I need to have 2 here. Okay, just balancing, guys. 2, 3, 2, yes. Then phosphorus, okay, I have 4 here, I have 4 here. I have 6 oxygens here, so I have to multiply this by 3. Is that it? Multiply by 3. Yes, multiply by 3. Okay, NH3 to produce H2 plus N2. Okay, 3 hydrogens here, 2 hydrogens here. Obviously, multiply this one by 3, multiply this one by 2. That way there's 6, 6. Okay, but now I have 2 nitrogens, 2 nitrogens. Is it balanced? Yes, 2, 2. Adi, it's easy, it's cool, it's calm. Okay, easy. Okay, then C2H5OH plus O2 to produce H2O2 CO2. Okay, let's start with the carbons. Here I have 2, so I should obviously have 2 here. Okay, let's move on to the hydrogens. Here I have 6. Here I have 2, so it should become 3. Okay, what do I have now? I have 4 oxygens here, and I have 3 here, so that's 7. So I multiply this by 7 over 2. But we said we want whole numbers, right? So we want to get rid of this fraction. So what do? We cancel it, and we multiply everything by 2, right? So this becomes 7, this becomes 6, this becomes 4. And if you check the answer over here, it'll be 3. Wait, there's something wrong. Be careful to note that all atoms are present in both. Oh shit! I balanced it wrong. Okay, wait, let's do this one again. Okay, 2 carbons, 2 carbons. Okay, 6 hydrogens, so I multiply this one by 3. Okay, here I have 4 oxygens. Here I have this one. See, I forgot about this guy here. So if I multiply this one by 3, it's gonna become 6, and then you add this one here and 7. So it's balanced on both sides. Okay, so if you're in a situation like this where you have an extra oxygen, just subtract. See, you have 7 here. Okay, just subtract the 7 by this one oxygen here, becomes 6. So how do I get 6 oxygens? Just multiply by 3. Part B, let me erase all this. Write the balanced equation for a reaction between pentane, C5H12, and oxygen to give water vapor and carbon dioxide. Okay, so I think you start by writing C5H12 plus O2 oxygen to give water vapor H2O plus CO2, and then now I think you should balance C5, so multiply this one by 5. Okay, and you have 12 here, so multiply this one by 6. Now check your oxygens. 6, and then here you have 10, so 16, so you put an 8 here. Is that the same? Yes. Okay. What's next? Whoa. Okay, carbon burns in air according to the following balanced equation. Okay, what mass of carbon dioxide can be produced by 36 grams of carbon? Okay, so you know, actually no, I won't. I'll just stay here. So we're basically this whole section is RR and GR. Okay, what mass of carbon dioxide can be produced by 36 grams of carbon? So here we have 12 grams of carbon in our RR and GR. Okay, in our RR, it's 12 grams of carbon because it's 1 mole, and 1 times C, which is 12, is 12. Okay, so 12. And what do I have given? 36 grams. Okay. what do we want? We want carbon dioxide. What do I have in my RR for carbon dioxide? It's 1 mole of carbon dioxide, and 1 mole of carbon dioxide is 12 plus 32, because oxygen O2, 16 times 232, it's going to be 44. Okay, in my GR it's X. So you cross multiply and you should get 132, I think. Where am I? Okay, that's a lot. I think it's 132. Yeah, see how they did it, just like this. Okay, question 9. Iron reacts with I know this one. Iron reacts with chlorine to produce ferric chloride. The equation of the reaction is represented below. Balance. Okay, since you have 2 here, 3 here, we start by multiplying this by 3, multiply this one by 2. Now you have 2 Fe, so multiply this one by 2. Write the reacting ratios in moles. Okay, write it in moles. Basically, you say 2 moles of Fe or iron reacts with 3 moles of chlorine to produce 2 moles of FeCl3. I think. I'm not sure. Yeah. Oh, okay. Yeah, you could say this. And what I said also is correct. How many moles of iron are required to form 4 moles of FeCl3? So what's our RR? What's our GR? Okay, what we have given is 4 moles of FeCl3. In our RR, it's 2 moles of FeCl3. Okay, in my GR, it's 4. Given 4. Okay, so in my reaction, I have 2. Given, I have 4. What do they want? They want iron. Okay, so I go to iron. What's my RR for iron? It's 2. What do we want? It's X, right? We don't know how many moles. Cross multiply, obviously, you're going to get 4 moles. Yeah, you should get 4 moles. Okay, part D, what mass of FeCl3 is produced when 35.5 grams of chlorine is consumed? So again, RRGR. Okay, what do we have given? 35.5 grams of chlorine. So we go to chlorine and we put in our given 35.5. In our reaction, how much do we have? Okay, Cl2, okay, Cl, I think Cl is 35.5 from your periodic table. It should be given. 3Cl2 is 3 times 2 times 35.5. Okay, which is 3 times 71, which is 213. Okay, so 213 in my reaction. Okay, what do we want? We want the mass of FeCl3. Okay, FeCl3, the molar mass of FeCl3 is, let me see, molar mass of FeCl3, 160, just take 162, I guess. How did you get 3 times 55? Okay, 162.5. Let me go back to it. Yeah, 162.5. Okay, so FeCl3 is 162.5. It's 2 moles of it, so it's 2 times 162.5. So it's gonna be 2 times 162, 324, 325. Okay, how much do we want? It's X. So cross multiply. Just check the solution. What's the answer? Over here. No, go back up, bro. Okay. They found the moles, and then they found the mass. Yeah. Okay. See, that makes sense, I guess. Yeah, that would make sense. Okay. My way also works. Whatever you guys want. They use the moles. 35.5 grams of Cl is actually 0.5 moles. So they put it as 0.5 moles, and then Cl3 is 2 moles. They cross multiply and they got that X is going to be 0.33 moles. Then they used N equals M over M, and they multiplied 0.33 times 162.5. They got 54.17. Yeah, okay, I guess that works. Whatever you want. What mass of Fe is consumed in the process when 35.5 grams of chlorine reacts? Okay, so let me. So what mass of Fe? So same thing now. Same number. Why did I delete them? Oh my god. It was 200, 71, 213.5. Yeah, and then the GR given chlorine is 35.5. But now they're asking for Fe. What mass of Fe is consumed? Okay, Fe here is 2 times 56, it's 112. Okay, because Fe equals 56. 2 times 56, 112. In X, we don't know how many grams we have, so X. Cross multiply. Did they use mass in the solution when they use moles again? No, they use moles. Okay, you get 18.7. Yeah. Question 10. How many? What does the term standard temperature and pressure mean? Okay, it means 0 degrees Celsius and 1 atmospheric pressure, I think. Yeah, 0 degrees Celsius and 1 atmospheric pressure. I remember this question always comes. Carbon burns in air according to the following equation below. What volume of oxygen at RTP will produce 4 moles of CO2? So again, do RR and GR. RR, GR. What do I have given? 4 moles of CO2. So I go to my CO2, given 4 moles. How much do I have in my reaction? I have 1 mole. Okay. What volume of oxygen at RTP? Okay, oxygen, they want volume of oxygen. Okay. Since it's RTP, RTP equals 24. Okay. Okay, RTP is 24. So I have 1 mole of oxygen. So 1 mole of oxygen is going to give me 24 dm cube, right? Do I know how much it's going to give me when I have 4 moles? No, so I just put x. So I cross multiply and you should get 96. I think 96. Yeah, 96 dm cube. Okay. Question 12. Consider. Okay, we have a lot from this section. Question 12. Determine the volume of N2 measured at RTP conditions that reacts completely with 12 grams of H2. Same thing, RR, GR. Okay, I guess you should use the moles. You should find the moles. 12 grams of H2 is N equals M over M, and H2 is 2. So 12 divided by 2 is 6. Okay, so we have 6 moles given of H2. Okay, and in my reaction, I have 3 moles of H2. Okay, and they want the volume of N2. Okay, in my reaction, I have 1 mole of N2. That means 24. Right, since it's RTP, RTP is 24. So 1 mole of N2 is 24 dm cube. How many do I have when I have 12 grams? We don't know, it's just x. So I cross multiply and I should get 48. Should be 48. 48, yeah. Part B, determine the volume of NH3 produced under the same conditions. Okay, so same thing now, but we want the volume of NH3. So we have 2 moles of NH3, so 2 times 24, that's 48 in my reaction, right? Okay, how much do I have when it's 6? X, right? Cross multiply and I should get 96. Yeah, 96. Then part C, if 33.6 dm cube, okay, so let's rewrite this. 33.6 dm cube of H2 react completely at STP, determine the number of moles of N2 needed. Okay, so what's given? 33.6 dm cube of H2. So let's go to H2. We put 33.6 dm cube. Okay, and it's at STP. Remember, STP is 22.4. Okay, in my reaction, I have 3 moles of H2. So 3 times 22.4, which is going to be 67.2. I think 67.2. Okay, what do we want? We want the moles of N2. Okay, the moles of N2 here is 1 in my reaction. So how much will I have when I have 33.6? It's going to be X. Cross multiply, and you should get 0.5, I think. 0.5, yes, 0.5. By the way, please pay attention in your written parts to significant figures. I'm sure they will deduct marks, 100%. A piece of potassium metal is lowered into a bottle of chlorine gas and a reaction takes place. KCl is formed. Write the balanced equation for the reaction, okay? Potassium metal is K, okay? Okay, and we're lowering it into chlorine gas. And I think all of you know that chlorine gas is Cl2, not Cl, it's Cl2. Okay, because chlorine is diatomic. Okay, so K plus Cl2 to produce KCl. We want to balance it, so obviously multiply here by 2, and then here you're going to have to multiply here by 2. Okay, since now to make this 2 chlorines, and then once you made this 2 chlorines, this became 2 potassiums, so you have to put 2 potassiums here. How many moles of KCl could be formed from 3.55 grams of Cl2? So you do RR, GR. What's given to me? 3.55 grams of Cl2. How 3.55. What do I have in my reaction? I have Cl2. They gave me Cl is 35.5. So Cl2, if you do it on calculator, it's 71. Okay. How many moles of KCl? In my reaction, it's 2. So given, it will be X. Cross multiply, and it should be 0.05. I think 0.05. 0.1. Is it? Wait, let me see. 2 times 3.55. Okay, yeah, I did the math wrong. Okay, yeah, if you get 0.1 in your calculation. Okay, question 14. Propane burns in air. According to the following balanced equation, what mass of C3H8 is required to react with 80 grams oxygen? Again, RRGR. We're pretty much repeating ourselves with these questions, guys. Given 80 grams of oxygen, hot 80 grams. Okay, let's go to oxygen. We have 5 moles of oxygen, and 5 times O2. O2 is 32 because 16 times 2. Okay, and this is going to be 160, I think. 160. Okay, what do they want? They want the mass of C3H8. Okay, what do I have in my reaction? C3H8 is going to be 36 plus 8, 44. Okay, 44 in my reaction. So in my GR, how much is it? X. Okay, cross multiply, you should get 22. Yeah, 22 grams. The molar mass parts, and I add them in my head because I think you guys all know how to do it. I'm not explaining how to find the molar mass. Just add them up. Consider the reaction between hydrogen and oxygen to produce water, which releases 284 kilojoules per mole of H2. Okay, how much heat is released when 0.2 moles of H2 are used? Okay, so for 1 mole of H2, okay, I get 284. Okay, how about when I have 0.2 moles? Okay, let's put mole. I'm gonna get X kilojoules, right? So obviously you're gonna cross multiply, and it should be divided by 5. How much do you get? 56.8. Okay. How much heat is released when 8 grams of oxygen are used? Okay. Okay, for part B, you're gonna have to write the equation. Okay. So hydrogen and oxygen to produce water. So H2 plus O2 to produce H2O. Obviously, you have to balance it. Since you have two O2s here, you have to multiply this by 2. And since you have now 4 hydrogens, you have to multiply this by 2. Okay. Now that you have the reaction, okay, we can add the energy at the end. Okay. You know what? Since they want it per mole of H2, let me rewrite this. Okay, produces H2O. Okay, I can balance this by just putting 1 over 2 over here. Okay, since they want it per mole of H2, so it's 284 kilojoules. Okay, how much heat is released when 8 grams of oxygen are used? Okay, so again, RR and GR. What's given to me? 8 grams of oxygen, right? So 8 grams down here. Now it's half O2. Okay, O2 is 32, half of 32 is 16. Okay, so my RR is 16 grams. How much do they want? They want the heat. Okay, in the reaction, it's 284. So in my GR, it's going to be cross multiply, and you should get 142. Yeah, 142. Question 16. ما بيخلصوا ليه؟ this is the last one. Okay, balance the equations for the decomposition of nitrogen trifluoride, NF3, and nitrogen trichloride, NCl3. Base each equation upon the production of 1 mole of N2. Huh? What? What do they want? They want to balance these? Okay. Since you have 3 here, 2 here, just multiply this by 2, multiply this by 3. Now it's balanced, obviously, 2 nitrogen, 6 fluorine, 6 fluorine. Okay, NCl3, okay, you have 3 Cls, and here 2 Cls. Multiply this one by 2, multiply this one by 3. Okay, and then again, 2 nitrogen, 2 nitrogen. Is that it? 2, 3, 2, 3. Yeah, okay. Rewrite the equations to include the information that the decomposition of NF3 is endothermic, absorbing 232 kilojoules per mole of N2. Okay, and that the decomposition of NCl3 is exothermic, releasing 457 kilojoules per mole of N2. So now we have to rewrite these. Okay, so let's work with the first one. Okay, since it's endothermic, that means we're gonna place the energy on the reactant side. Okay, so we're gonna rewrite it to NF3. Okay, plus 232 kilojoules to produce N2 plus 3F2. Okay, they said per mole N2, and we actually have 1 mole of N2, so there's no need to change the amount of energy we're using. Okay, then same thing here, except they're saying exo and it's releasing. That means you place the energy on the product side, so you're going to get 2 NCl3 to produce N2 plus 3Cl2 plus 457 kilojoules. Okay, is that correct? Yes. I think we're done from this section. Yeah. Okay. Chapter 5. A sample of 0. I think this is the PV equals nRT. A sample of 0.1 moles of oxygen gas and 0.4 moles of nitrogen gas are placed in an empty container of volume 20 liters. The total pressure in the container is 0.58 atmosphere. Find the volume of the oxygen gas. Okay. They try to trick you with all of this mumbo jumbo words. Okay. Please remember it's a gas, so it takes the volume of its container. So it's just 20 liters. Okay. Yeah. There's literally, you don't need anything. Okay. Volume of oxygen always equals the volume of the container because it's a gas. Okay. Okay. Yep. Okay. هول هن PV equals nRT. Okay. A certain mass of helium gas was placed in a cylinder fitted with a piston at 25 degrees Celsius. The volume and pressure were measured to be 3 dm cube and 120 mmHg. Okay, if the piston was pushed till the volume reaches 2 dm cube while maintaining a constant temperature, how much would the pressure be? Okay, I'm gonna work over here on the side. Uh, let me move this. So remember, we're using P1 V1 equals nRT1 and P2 V2 equals nRT2. Okay, قالوا they didn't talk about the moles. Okay, they are is always cancelled. Okay, and they said constant temperature فيعني T1 و T2 we cancelled them. So we're left with P1 V1 equals P2 V2. Okay, هلا pressure 1 is 120 mmHg. For 120 times V1, which is 3, okay, equals V2 2 times P2, which we don't know it. فأكيد you divide, you should get 180 mmHg as your answer. نزل تحت 180. This is نحن is the density question in the material? Okay, that's a lot. That's a lot. Okay. I saw up. It might come. I mean, they only said grids, but in case it does come, density is PM over RT. M is molar mass. P. What is P? Wait, what is P? Pressure, I think. Yeah, P is pressure in atmosphere. Okay, it has to be pressure in atmosphere. T is temperature in Kelvin. المهم, let's continue. Question 11. Certain mass of helium gas was placed in a cylinder fitted to the piston. Okay, same question. I mean, these come every question, every exam. Okay, with a piston 25 degrees Celsius, volume pressure were measured to be 3 and 120, whatever. Gas is heated to 125. Maintaining volume, what will the new pressure be? نفس الشيء. P1 V1, P2 V2. Okay, P1 V1 equals nRT1. P2 V2 equals nRT2. اوكي شو بدهم constant volume ف V و V R and they're cancelled because they didn't really mention the moles. اوكي هن غيروا temperatures. Yeah, the temperature changed. Okay, so we're left with P1 over P2. Okay, here we're left with P1 over P2 equals T1 over T2. Please تذكروا انه temperature must be in Kelvin. Okay, don't forget. Pressure 1 was 120 mmHg. فبتحط 120. Okay, over pressure 2, we don't know it. New pressure, we're trying to find it. P2 equals I think some people might not be able to see my screen. Let me move to the right a bit. 120 over P2 equals T1 over T2. Temperature 1 was 25 degrees Celsius, but it must be in Kelvin, so you add 273. So it's going to be 293. No, 298. Okay, 298 over T2. We said 125. If I just add 273, and it should be 398. Okay, cross multiply, and you should get. What do you get? I don't know. I know. Where am I? Where am I? Where am I? So the answer is gonna be 160. Okay. Question 12. Ya Allah. A certain mass. Okay. I'm gonna just speed these up. Okay. P1 V1 equals nRT1. Okay. P2 V2 equals nRT2. Okay. What's constant? Let me see. Volume of pressure. Okay. Okay. I think they changed everything. Yeah, they changed everything, but we only cancel NR. Okay, so it's gonna be P1 V1 over P2 V2 equals T1 over T2. Okay, P1 I think is 120 mmHg. Okay, times V1 volume 1 was 3 dm cube. Okay, over P2, which is 90. Okay, we're trying to find V2 equals T1 which is 25 degrees. In Kelvin, that would be 298 because you add 273. And then T2 is 125 plus 273, that will be 398. Cross multiply, you should get, what do you get 5.3. Yeah, 90 V2. Yeah. Question 13. Certain mass of helium was placed in a cylinder. Okay, same thing. I will speed things up. P1 V1 equals nRT1. P2 V2 nRT2. They said pressure is constant. Okay, so cancel P with P. R with R, N with N. You're gonna get V1 over V2 is T1 over T2. Okay, first volume was 3. Okay, we want V2, we don't know it. T1 was again 25 degrees Celsius. In Kelvin, that's 298. T2 125, so it's going to be 398. Cross multiply, and you're going to get, I don't know, how much do you get? 4. Yeah, okay, 4. A sample of 20 grams of helium gas, 2 grams of helium gas were placed in a container at 25 degrees Celsius. The pressure was measured to be 120 mmHg. If 6 more grams of helium gas were added to the container while maintaining the temperature and volume constant, how much would the pressure be? Okay, now since we're talking about grams, we need to keep the moles. We can't cancel the moles anymore. So we're going to do P1 V1 equals nRT1. P2 V2 is nRT2. So R with R, what did they say? Temperature and volume constant. Okay, so temperature and volume we cancel. So P1 over P2 equals N1 over N2. Okay, our first pressure was 120 mmHg. Our second pressure, we're trying to find it, P2. Okay, the first moles, okay, helium is 4. So they gave me 2 grams. So N equals 2 over 4, M over M, yeah? 2 grams over molar mass 4. So 0.5 is my first moles. Then they said my second moles was 6 more grams. So you just take these 2 grams, you add 6, it's 8 grams. Okay, now can I find the moles when I have 8 grams? It's going to be N equals 8 over 4, because the molar mass of helium is 4. So you get the moles is 2. So 0.5 over 2. If you cross multiply, you should get P2 is 480. 4.8 times 10 to, okay, why? Okay, just 480. I think 4 significant figures, because yeah, they want 2 significant figures. Please again pay attention to significant figures. Okay, I think I don't know. I'm not sure whether the significant figures of the mass given to you, the molar mass given to you counts. Anyways, please pay attention to different significant figures. Okay, a sample of 2 grams of helium was placed in a container at 25 degrees. Pressure was blah 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 blah. Okay, well, then I just solve this. Let me do it again. P1 V1 equals nRT1. Okay, P2 V2 nRT2. Okay, temperature, pressure constant, temperature, pressure. Okay, V1 over V2 equals T1 over T2. Okay, so first volume. This one was asking for pressure. This one's asking for. Okay, it's the same numbers, also. Okay, volume 1 is volume 1 is not given. Wait, I'm tweaking. At 25 degrees Celsius, the pressure was measured to be 120 mmHg. If 6 more grams were added, okay, there has to be something I can't see because you should need the first volume. Volume 1 is 5 liters. Okay, من وين جابوا لي 5 liters ما بعرف. Sample. Okay, 6 more grams. Okay, the 5 liters isn't in the question, but okay, let's say they gave you the volume 1 is 5 liters. Okay, so volume 1 is 5. We want V2, right? Equals T1, which is 25 degrees. Wait, and an T1. Why am I using T1? Sorry, N1 over N2. N1 over N2. Okay, the first moles, again, 2 over 4, because M over M, 2 divided by the molar mass. Okay, 0.5. Okay, and then the second mole, they added 6 more grams, so 2 plus 6 gets me 8 grams. And then how many moles do I have when I have 8 grams? 8 over 4, 2 moles. Okay, multiply by 4, multiply by 4. Okay, cross multiply. Well, basically cross multiply, you get 20, I think. 20 liters. Okay, since we are dealing with the same gas and water mass is constant. What did he say? How much was it? Or okay. لا 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 صعب. Okay. Question 15. When 1 kilogram of helium is filled into an empty balloon at 27 degrees Celsius, the pressure becomes 760 mmHg. Find the okay. This also comes. These are all AMS questions. يعني. أكيد there's no P1, V1, P2, it's just one. Okay, they want you to use the whole equation. PV equals nRT. Pressure is okay. They want it always. Pressure should be in atmosphere. 760 mmHg. You convert it to atmosphere by dividing by 760. Okay, so you're gonna get one atmosphere times the volume, we don't know it, equals nRT. Moles. How many moles of helium do I have when I have 1 kilogram, which is 1000 grams? Okay, do 1000 divided by 4, you get 250 because m over m, mass divided by mole mass. 1000 divided by 4 is 250 moles. So n is 250. R is given 0.082. 0.082. والtemperature is 27 degrees Celsius. add 273 بيطلع لك 300. So times 300. Okay, and I don't know what's the answer. You get yeah 250 times 0.082 times 300 divided by 1, 6150. And again, pay attention to significant figures. 3SF, keep it as 6.15 times 10 to the power of 3. I think we're done this section. أخيرا. Okay, define effusion and diffusion. Okay, effusion, I think, is through a pore. Is the movement through a pore. Yeah, effusion is the process by which gas particles escape through a pore, and diffusion is just the random movement. Okay, you could say by which gas particles mix, bouncing off in all directions, or you could just say is the random movement of gas particles bouncing off in all directions. Equal number moles, and helium gas were allowed to effuse out of a container at the same temperature. Compare the rate of effusion of these gases. Always remember V1 over V2 equals radical M2 over M1. Okay, so let's call V1 the volume of CH4. Okay, sorry, velocity of CH4. Okay, and V2 will be the velocity of helium. Okay, actually, you know what? Let me put the lighter gas on top because that makes solving way easier. Okay, we're gonna put velocity of helium on top, and then the velocity of CH4 at the bottom. Okay, radical equals radical M2 over M1. So remember, the masses are flipped. So I don't put the mass of helium, no, I put the mass of the one at the bottom. CH4 is 16, and then the mass of what's it called? Helium is 4. Okay, now look, here it's an easy number because radical 16 over 4 is 2. Okay, but sometimes they won't give you an easy number, so I would advise you to square both sides. Okay, so you're gonna get velocity of helium squared over the velocity of CH4. Whoa, what am I writing? CH4 squared. Okay, equals 16 over 4. Okay, which equals 4. Okay, so 4 times velocity. Okay, you can just then you can square root both sides. It's gonna be okay. Well, let's continue solving. I know we can't square. Okay, cross multiply 4 times velocity of CH4. Okay, squared equals velocity of HE squared. Okay, then you just square root both sides. You're gonna get 2 times velocity of CH4 equals velocity of helium. So then you can say helium is twice as fast. Why I went through all this extra steps is because sometimes in the exam they won't give you perfect numbers. So what I did now is, if they don't give you perfect numbers, that can be square rooted. But in this case, radical 16 over 4 is just 2. Okay, and you can just cross multiply the 2 to the CH4, and you're going to get 2 times velocity of CH4 directly without having to square or anything. 2 times velocity of CH4 equals the velocity of helium, and then you can infer from this directly that helium is twice as fast as CH4. Okay. Okay. Skip. Okay, so we don't have much left. Question 15, 17, and 22, 20. Okay, we have five questions left. Okay, not much left. خلاص, let's get them over with. If 1 mole of a solute is dissolved in enough water to make 2 m cube of solution, what is the concentration of the solution? Always remember C equals N over V. Okay, so the moles is 1 over the volume, which is 2, which is 0.5. Pretty straightforward. How many moles of a salt should be dissolved in 0.5 dm cube to make 0.25? Always remember N equals CV. Just cross multiply. Just play around with the formula. Okay, you're gonna get 0.25 times 0.5. Okay, and you should get 0.125, I think. When أنا بعدني هون over here, part B, yeah, 0.125. And then part C, what is the volume? Volume is N over C, so it's gonna be the mole 0.2 over the concentration 0.1, and you should get 2. Question 17. Write the balanced equation of dissociation of the following ionic compounds in water. Okay, so how do you write dissociation? BiI2. Okay, it would be helpful if you had a periodic table. Uh, periodic table. Periodic table. Okay, so Ba is over here, group 2, so the charge is 2 plus. Let's go back. Where am I? It's gonna be Ba2 plus. Okay, and then I2 is I is group 7. Just to show you, group 7 should be minus. I is over here, so it's minus 1. Okay, so it should be, go back to the question, B plus I minus, but you need to balance, so it will be 2I minus. Okay, let me make sure, is that the correct answer? 17. Yeah, 2I minus. Okay, then K3N produces, K is in group 2, I think. K group 1, okay. Acetylena crypsis, they're the alkali metals. Okay, so it's K plus N, nitrogen is in group 5, N3 minus, oh, N3 minus. Okay, then balance it, you're gonna have 3K plus. Okay, that's it. Okay, and then this last one, you put it to produce Ca2 plus, because calcium is in group 2, and NO3 is always minus. Okay, I think is it minus? NO3, is it NO3 minus or NO2 minus? Yeah, so it's part of that one table in the book that you guys should memorize. I'm 1 hour into recording, so I'm not in the mood at all to pull up the table from the book. But NO3 is minus. Okay, it's NO3 minus. Okay, then to balance it, since you have 2 here, you don't put a 2 down here. No. You always balance by putting coefficient. Okay, and is that correct? Yeah. And by the way, if you didn't know, but you know calcium is 2 plus. Okay, by the way, the sum of charges should always be 0. They should always cancel out each other. Okay, so you obviously know it's like, let's say you didn't know the charge. You obviously know it's gonna be 2 NO3, right? Okay, since you have to balance it, it's gonna be 2 NO3. Okay, since you have 2 plus here, okay, and I'm gonna multiply 2 times the charge, let's say 2x, okay, equals, it should also equal that other charge. So divide by 2, that's 1. And just in case, maybe you didn't know, just that would be a way to find it. Okay, question 22, deduce the empirical formula. Okay, basically they want the compound. Okay, just crisscross. 3 goes here, 2 goes here, it becomes Al2S3. Wow. Okay, NH4 plus goes here, so it doesn't but the 2 goes here. Okay, so it's gonna be NH4. Okay, the 2 goes outside. Okay, if it's already a compound, the subscript goes outside. Okay, and then SO4. Is that correct? Why does that look wrong? Whoa. Okay. Yeah, okay. It looks correct. This one, again, crisscross. Okay, it's gonna come, 2 goes to Fe, so Fe2. And then the 3 goes outside of CO3. Okay, CO3. And then the 3 goes outside. Okay, because it's already a compound. There you go. Question 23. Magnesium chloride dissolves in water for. Oh my god. Astaghfirullah. Ya Allah. Ya Allah. Ya Allah. Okay, we're gonna have to do concentration of ions. Uh, Let me put it inside the whiteboard. Okay, MgCl2 dissolves in water to form Mg2 plus. Okay, NCl. Okay, sample of 0.15 moles of MgCl2 is dissolved in water, diluted to 1.5 dm cube. What's the number of moles of magnesium? Okay, blah 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 blah. Okay, remember when you find a concentration of ions, step one, dissociation reaction. Okay, dissociation reaction. Okay, so you split up the MgCl2. It becomes they said Mg2 plus and Cl minus. Okay, let's balance it out. 2Cl, so let's put it 2 here. Okay, we said it's 0.15 moles of MgCl2. So 0.15 over here. Okay, step 2 is to find the moles for everything, right? Find moles, right? So I have 0.15 here. Since it's the same coefficient for the Mg, so it's also going to be 0.15. But this is 2, so we multiply the moles by 2, is going to be 0.3. Alright, they just wanted moles? Oh, okay, this is calm. So just be 0.15, 0.3. Is that it? Oh, okay. Okay, calma. That's nice. 24. Okay, question 24. Okay, 0.4 dm cube of a solution which contains 0.1 moles of Na2SO4 was mixed with 1 dm cube which contains 0.1 mole of zinc chloride. Calculate the concentration of all ions. Okay, this one you actually have to apply the steps and stuff. Yo, what? Okay, المهم, first step, always remember, first step is dissociation reaction. Okay, dissociation reaction. Let's write the dissociation reaction for each one. Okay, we have Na2SO4, so Na2SO4, and then I'm gonna write find moles for the second step. Okay, because I'm gonna do both of them at the same time. Na2SO4 to produce Na plus and SO4 2 minus, but it's 2Na to balance. Okay, and then the second one would be ZnCl2 to produce Zn2 plus Cl minus, and it's 2Cl minus to balance. Okay, then find the moles. هني قالوا لنا 0.1 moles of Na2SO4. This one has 2 as its coefficient, so multiply by 2 to be 0.2 moles. Okay, this one has 1 as coefficient, so it stays the same as the one for Na2SO4, so it will be 0.1 mole. ZnCl2 as well is 0.1 mole. Okay, Zn2 plus, same coefficient for 0.1, dollar 0.1. 2Cl multiplied by 2 is 0.2 mole. Okay, how do we find the concentration? Concentration is C equals N over V total. Remember, it's V total. And in this case, V total is 1.4 dm cube because I just added the volumes of both solutions, 0.4 and 1 dm cube. Okay, so let's start. For the concentration of Na2SO4, concentration of Na plus. Okay, it's equals the moles of Na plus, which is 0.2 divided by 1.4. And you get, I don't know, bro. 1 over, I don't know. And then the other one's gonna be concentration of SO4 2 minus, which is the moles of SO4, which is 0.1 over total volume, which is 1.4. And then concentration of Zn2 plus is going to be moles of Zn2 plus, which is 0.1 over total volume 1.4. Then the concentration of Cl is going to be moles of Cl 0.2 over V total 1.4. Okay, I don't have a calculator. I think the over here, yeah, you get this. Okay, it's the same thing we got. Yeah, just do it on a calculator. Okay, so I guess that's it for this recording. 1 hour and 9 minutes. Thank you so much for watching, and good luck in your chemistry final.